Uh, this is uh, chapter 7, lesson number 2, function rules. Let's start by some new terms. A sequence is a list of numbers in a specific order. Each number in the list is called a term of the sequence. Like, for example, if I have this sequence 2, 5, 8, 11, and so on, this is a sequence. It has a certain pattern. Another sequence like 3, 6, 12, 24, and so on. This is a sequence. It has a certain order. Each number in the list is called a term of the sequence. We have two types of sequences, arithmetic sequence and geometric sequence. Arithmetic sequence can be found by adding the same number to the previous term, like this one. From 2 to 5, we can add 3, plus 3, and from 5 to 8, also plus 3. From 8 to 11, also plus 3. This is called arithmetic sequence. Now, for the geometric sequence, each term is found by multiplying the previous term by the same number. Same number means no change. Same number means no change. So, in arithmetic, we find it by adding the same number. In geometric, we find it by multiplying the same number. Like here, this is multiply 2. And here also multiply 2. And here also multiply 2. So we say this is geometric sequence. So we have two types of sequences, arithmetic sequence and geometric sequence. Arithmetic sequence if we are adding the same number, geometric sequence if we are multiplying the same number. So for arithmetic and geometric sequence, determining if a sequence is arithmetic or geometric can help you find the pattern. When you know the pattern, you can continue the sequence to find missing terms. Like example 1, 7, 14, 21, 28. You discover that we are adding 7 all the time. Adding 7 all the time, so you can deduce the next number, which should be 35, then 42, then 49, and so on. Like this sequence, for example, 2, 4, 8, 16, you discover that multiply by 2, multiply by 2, multiply by 2. So if you continue multiplying by 2, you can find 32, 64, 1 to 8, and so on. See how easy the lesson is? Now let's do these problems. Problem A, I have 0, 15, 30, 45. So it's clear that we are adding 15, adding 15, adding 15. So next terms are, after 45 will be 60, then 75, then 90. In problem B, this is 4.5, then 4, then 3.5, then 3. So we are subtracting 0.5, subtracting 0.5, subtracting 0.5. So if you subtract again 0.5 after 3, this will give you 2.5, then 2, then 1.5. Enough three terms to show that you really understand what is happening. Here, it's clear that from 1, 3, 9, 27, we are multiplying by 3. So here multiply by 3, multiply by 3, multiply by 3. So multiply by 3 again, this will give you 81. Multiply by 3 again will give you 243. Multiply by 3 again will give you 729. In problem D, 3, 6, 12, 24, so it's clear that we are multiplying by 2, multiplying by 2, multiply by 2. So next three terms will be 24 multiplied by 2 will give you 48. 48 multiplied by 2 will give you 96. 96 multiplied by 2 will give you 192. See how easy? Now, how can we find a rule? A sequence can also be shown in a table. The table gives both the position, pay attention for this word, position is always 1, 2, 3, 4. The position of each term in the list and the value of the term. So here is the position and here is the value. Position means 8 is considered as the term number 1, and we follow the order. 16 is the term number 2, 24 is the term number 3, 32 is the term number 4, and so on. So these are the positions and these are the values. Means term number 1, it is 8, term number 2 is 16, term number 3 is 24, term number 4 is 32, and so on. You can write an algebraic expression to describe a sequence. The value of each term can be described as a function of its position. This is what we are seeking now. This is our aim. Value of each term can be described as a function of its position. In the table above, the position can be considered the input and the value of the term can be considered the output. So we need the position to be the input and we need the value to be the output. Means if I give you 1, how can you get 8? If I give you 2, how can you get 16? If I give you 3, how can you get 24? This is the value, this is the relation between the position and the term. Of course, in this case, we are going to say it's like if the position is n, so the value will be like 8n because 8 times 1, 8 times 2, 8 times 3, 8 times 4, and so on. So this is our function 8n in this case. Now, the same is happening here. Position is the input. This is position is the input, like 1, 2, 3. Position is always 1, 2, 3, 4, 5, and so on. And the value is the output. So from 1, how can you get 3? From 2, how can you get 6? From 3, how can you get 9? It's clear that we are multiplying by 3. So if the position is n, the value is 3n. So this is our function, 3n. Now let's solve some problems based on this idea. How can we relate between the position and the value? Use words and symbols to describe the value of each term as a function of its position, then find the value of the 8th term. So, words, then symbols to describe the value of each term as a function of its position, then find the value of the 8th term. So in problem E, from 2 to 12, from 3 to 18, from 4 to 24, from 5 to 30, what is happening? It's clear that we are multiplying by 6. So, value equals position times 6. This is in words. Now we need to find it in symbols, means 6n. Now finally, this is 6n here. Finally, we need to find the 8th term, so it will be 6 multiplied by 8, which is 48. Now in problem F, how come from 3 we can get 7, from 4 we can get 8, from 5 we get 9, from 6 we get 10? Of course, we are adding 4, so value equals position plus 4, means if the position is n, so this will be n plus 4, here n plus 4. And now we need the 8th term, so replace the n by 8, so 8 plus 4 will give us 12. So here we are going to say this is 6n, 48. And here we are going to say n plus 4, 12. Now the guided practice. Describe the relationship between the terms in the sequence 13, 25, 52, 104. Then write the next 3 terms. This is normal question because we need the relation between terms. We don't need position like this one. This is normal question. Relation between terms means from every term to the other, from every term to the other. So we have 2 types of questions in this lesson. The type of relation. Relation means how can we get a term from another term? And the type of this question, how can we get the value from the position? Let's focus on the first type now. Describe the relationship between terms of the sequence 13, 26, 52. So adding 13, it's clear that we are adding 13 plus 13, and here also plus 13, and so on. But I think this is not adding 13 because here from 26 to 52, it's multiplied by 2. So it's not adding 13, it is multiplying by 2. This is not adding 13. This is multiplying by 2 times 2 times 2. And also from 52 to 100, 4 times 2. So we say multiply by 2. Now write the next three terms. So we need to, after 104, after 104 we multiply by 2. So this will be 208. Multiply by 2 again. So 416. Multiply by 2 again. So 832. Now in problem 2, use words and symbols to describe the value of each term as a function of its position. Means from 1, how can we get 2? From 2, how can we get 4? From 3, how can we get 6? It's clear that we are multiplying by 2, so this is 2n. So value equal position times 2 means 2n. And then find the value of the 15th. So 2 multiplied by 15, this will give you 30. Moving on. The table at the right shows the fee for overdue books at a library based on the number of weeks the book is overdue. Write a function rule to find the fee for a book that is X weeks. So from 1, how can we get 3? From 2, how can we get 5? From 3, how can we get 7? From 4, how can we get 9? It is multiplied by 2, then plus 1. So multiply 2, multiply x by 2, then add 1, means 2x plus 1. Let's write times 2 plus 1, 3, times 2 plus 1, 5, times 2 plus 1, 7, times 2 plus 1. So here is 2x plus 1. Write a function rule to find the fee for a book that is X weeks overdue. So we really wrote the rule. This is the rule, or you can say this is the rule. So it's clear that the lesson is easy. If you have any question, you can write it down in comments.